All right, ladies and gentlemen, we got number 11. A student mixes 50 milliliters of 1 molar barium hydroxide with 86.4 milliliters of 0.49 molar sulfuric acid. Calculate the mass of barium sulfate formed and the pH. Okay, well, let's look at this. Let's talk barium hydroxide first. All right, let's get the moles of each of these and find the limiting reactant and go from there, all right? Because barium hydroxide in our book is soluble, and sulfuric acid is obviously soluble, and so they're going to react to completion, let's say, okay? We got a pretty good case for that. And so for barium hydroxide, if we have 50.0 milliliters times every 1,000 milliliters, we have 1.00 moles, right? We get 0.05. And we have, what, 3 sig figs? All right, so that's how much we get there. Then we have our 86.4 milliliters of sulfuric acid. And every 1,000 milliliters, we're going to have 0.494 moles. And so if we do that, it looks like we get 0.0427. All right, so our barium hydroxide is going to react with our sulfuric acid. And we're going to get barium sulfate, which we're really interested in. And looks like we get water, right? 2 of them, which we're not caring about. And so if we have 0.0500 moles and 0.0427 moles, who's limiting? Well, it's a 1-to-1. So that means sulfuric acid is our limiting reactant. So minus 0.0427 moles and minus 0.0427 moles. So that means we have none there. And it looks like we have 0.0. That would be 0.73 moles. All right. Okay, so that's what we have there. But however, we have to add plus 0.0427 moles of product. So we have 0.0427 moles of BaSO4. How many grams is that? We don't really need to worry about the concentration of this because it's solid. All right, and so 1 mole of barium sulfate, right? Molar masses. Barium is 137.33. And we're adding that to sulfate, 32.07 plus 16 times 4. I get 233.4. So that means I get 9.97. Hopefully you get that too. I think that's what I get. All right, so that is the answer there. Now, KSP for this compound in our book right now is 1.1 times 10 to the negative 10. So we're going to assume that not much, if any, dissolves. Does that make sense? That to the, to the 10th, or the, so you got grams. We're not even to the milligram scale yet. Is dissolving. So I'm thinking we're pretty good, keeping it at 9.97 because KSP is so small. This, now, for hydroxide, we have a problem, right? So we have 0.0073 moles of BaOH2. And our new volume would be, well, let's do it this way. 50.0 milliliters plus our 86.4. All right, so that's our new volume. And we need to get this to molarity of hydroxide. So, of course, we're going to do 1,000 milliliters is 1 liter. And then we know that for every 1 mole of barium hydroxide, there are 2 moles of hydroxide. So if we do that, we take our 0.0073 times 1,000 times 2 divided by the 50 plus the 86.4. I'm getting 0.107. All right, and so it doesn't really care about the hydroxide concentration, it cares about the pH. So remember, pH plus pOH is 14. So pH equals 14, which is pKw, minus the pOH. So that means pH equals 14 minus the negative log of hydroxide. So the pH then would be 14 plus the log of our 0.107. So I'm getting 14 plus the log of 0.107. I get 13.029383777. So basically I get 13.03 as the pH. So we have 2 answers here. There's your pH. And there's our grams of barium sulfate. All right. So to recap real quick, we found out we had a reaction. We had a neutralization reaction, right? This is the base, this is the acid, this is the salt, this is the water, right? Neutralization, double replacement reaction. Strong and strong, all right? Even though it's only the first one, we're going to say it reacts to completion because this is a strong base, and that's pretty good approximation. So we found the volume and the molarity to get the moles. So we got the moles of both of our reactants. Found the limiting reactant, which was the acid. All right. And then I did it via an ice table. We found out how many moles of excess reactant were left and how many moles of product were made. And the moles of product, we went to grams of product. And so we got the grams of product, which is what they asked. And then from the moles of excess reactant, barium hydroxide, we figure out the concentration of just hydroxide. And then found the pH. If you have any questions, reach out. Otherwise, we'll see you in the next one.